The strongest El Niño in modern history hit California 11 years ago, and the state had one of its driest winters on record. Something stronger than that just arrived yesterday. Most people who followed 2015 took the wrong lesson from it. They remember the hype. They remember the drought that didn't end. What they don't remember is why, the specific mechanism that turned the strongest event ever recorded into one of Southern California's driest winters on record. That mechanism is still there, and it's the reason yesterday's arrival means something different from what most coverage is saying. So El Niño is present, not forecast. Present. NOAA, the American agency that monitors the oceans and atmosphere and issues the official climate advisories the country runs on, confirmed it yesterday. And the numbers they're tracking right now are doing something unusual. The anomaly in the core equatorial Pacific, the subsurface heat content, the forecast agreement from NOAA to Europe's primary modelling centre to the Australian Bureau of Meteorology. Every update for the past 6 weeks has come in stronger than the one before it. The median forecast from every major international model ensemble is now depicting at least a strong event. The majority are depicting something at the top of the historical record. There's a word that gets used for that: Super El Niño. It's not an official NOAA designation. Their term is very strong, but it means the same thing. Sea surface temperature anomalies above 2 degrees Celsius in the core region. It's happened 4 times in the reliable satellite record. 1982, 1997, 2015. Possibly now. The last time was 11 years ago. The sea surface temperature anomaly in the core Pacific region peaked above 3 degrees Celsius in 2015. Every major forecasting agency predicted a potentially drought-ending deluge for California. The models agreed. The meteorologists agreed. The headlines agreed. And then Southern California had one of its driest winters on record. So when people hear that 2026 is tracking to match or exceed 2015, skepticism is reasonable. You could be forgiven for thinking you've seen this before. What makes this one different isn't just the anomaly number. NOAA recently introduced a second measurement alongside the traditional index, the RONI, the relative ONI, designed specifically to strip out background climate warming and measure the El Niño purely on its own natural dynamics. The point was to prevent a hotter baseline from inflating ordinary events into apparent records. Under that adjusted measure, 2026 still tracks as potentially historic. The background wasn't padding the headline. The event itself is that strong. But the background is doing something else entirely. El Niño works as a temporary warming pulse. It liberates years of accumulated heat from the subsurface Pacific and dumps it into the atmosphere, raising global temperatures by roughly 0.2 to 0.4 degrees Celsius. That pulse is additive. It doesn't compete with the warming already baked into the climate. It stacks on top of it. In 2015, it stacked onto a planet running about 1 degree above pre-industrial levels. In 2026, it stacks onto 1.5 degrees. Climate scientist Daniel Swain at UCLA in Los Angeles put it directly: we have never experienced a strong El Niño amid pre-existing conditions this warm. The same natural event. Measurably different ground. In the winter of 2015, California got the El Niño it had been waiting for. The strongest in modern history by every available measure. The reservoirs were low. The drought had been running for 4 years. The state needed rain urgently, not eventually. Not eventually. The rain didn't come. Researchers at Scripps Institution of Oceanography, the University of California's Ocean and Climate Research Center in San Diego, spent the following year trying to understand what happened. What they found was precise and uncomfortable. The seasonal forecasts had predicted extreme wetness for Southern California. What actually occurred was extreme dryness. Dryness that, as the Scripps paper put it, exacerbated one of the worst droughts on record. Two extreme events. One predicted and failed to arrive. One that arrived without being predicted at all. The mechanism behind the failure comes down to something the El Niño forecast doesn't, and arguably can't, fully capture. 40% of California's annual water supply arrives in the form of atmospheric rivers. Not steady rain, not distributed precipitation across a wet season. Concentrated, powerful corridors of moisture that travel from the tropics across the Pacific and release when they hit the coast. An El Niño sets conditions that make those corridors more likely, but it doesn't guarantee them. Researchers at Scripps analysed more than 70 years of weather data and found that atmospheric rivers explained roughly 70% of the years when California's precipitation defied the El Niño prediction entirely. Years that should have been wet but weren't. Years that should have been dry but flooded. The teleconnection is real. The delivery mechanism has its own logic. And the state that had been promised relief watched another dry winter pass. The question for 2026 is whether the same thing happens again. The honest answer is that the setup going into this event is more aggressive than anything in the 2015 record. The subsurface heat content, the energy sitting below the ocean's surface waiting to drive the system, is running near 8 degrees Celsius above normal at depths between 50 and 800 feet. That's not surface temperature. That's the reservoir that feeds the event for months after it begins. In 2015, that reservoir was large. In 2026, every available instrument shows it larger. The forecast agreement from NOAA to Europe's primary modelling centre to the Australian Bureau of Meteorology is more unanimous at this stage of development than it was at the equivalent point in 2015. The rain has better reasons to arrive this time. Not certainty, better reasons. In the winters of 2022 and 2023, California got the rain it had been waiting years for. 9 atmospheric rivers in a single season. The Sierra snowpack hit 269% of normal in some locations. Reservoirs that had been rationing water filled past capacity. The hillsides across Los Angeles County went green in a way people who had moved there in the drought years had never seen. Grass and brush grew across slopes that had been brown and compressed for the better part of a decade. The following winter was wet too. Not as dramatically, but above average. The vegetation held. The hillsides stayed green through spring. Then the rain stopped. Summer 2024 ran hot and dry. October came without the early rains that sometimes break the heat. November passed. December arrived with temperatures that should have been impossible and almost no precipitation. By the time January 7, 2025 came, the day a wind event of near-historic intensity moved through the Los Angeles basin. The hillsides that had been growing for 2 wet years were desiccated to a degree fire scientists described as extreme. The Palisades fire started that morning. By the end of the month, 16 512 structures were gone. Climate scientist Daniel Swain had published a warning on his Weather West blog 3 days before the fires started. A prolonged and possibly extreme offshore wind event, he wrote, was coming. He had also spent the previous 2 years documenting the mechanism behind what made those hillsides so dangerous. Swain calls it hydroclimate whiplash. The wet years and the dry years aren't separate problems. They're the same problem in sequence. A strong El Niño doesn't reduce California's fire risk over time. In the years that follow a wet El Niño winter, the fire risk can be higher than it would have been without the rain, because the rain grew something. The 2025 fires were not a failure of drought management. They were, in part, a consequence of the rain. The whiplash doesn't stop at the hills above Los Angeles. The temporary sea level rise from a strong El Niño along the California coast runs between 6 inches and a foot. That sounds manageable, but communities like Pacifica, Sausalito, and San Rafael already flood during ordinary king tides, the kind that happen every year without any weather event at all. Add 6 inches to a king tide in a place already at the brim, and you don't get a flood warning. You get the parking lot, the ground floor, the road that closes. NASA researchers who modelled this scenario noted something that surprised them. Events like that, what hydrologists call 10-year floods with a 1 in 10 annual chance of occurring, could become commonplace along the California coast by the 2030s. Not during El Niño years. Every year. The researcher who ran the analysis said he had expected to be delivering that finding in the 2040s or 2050s. The timeline had moved without him noticing until the data showed it. That's what this winter is, not the worst case. The preview of the routine case. Swain, the scientist who documented the whiplash mechanism, who posted the fire weather warning 3 days before the Palisades fire, whose research on hydroclimate volatility was published the same week the fires started, said something in a public forum earlier this year that didn't make headlines. He said the whiplash is accelerating faster than the models predicted, that at current warming levels the models should be tracking observed reality fairly closely. They aren't. The data is running ahead of the theory. He said, something else is going on. We're not totally sure what it is. The person who built the most accurate framework for understanding California's climate volatility is telling you the framework is already behind what's happening. El Niño arrived yesterday. The rain may come. It may not land where it's needed. And if it does land, it will grow something. The question isn't what this winter looks like. It's what the scientist who understands it best doesn't understand yet, and what that gap is already producing while we're all watching the Pacific.